So, hi everyone. Thank you for joining the second part of our KACST Tokenomics series. My name is Jerry, and I'm from the tokenomics team, and we'll be presenting today. So, last time we had the head of tokenomics, Mo, as well, but unfortunately he's unable to make it today. So, I'll be taking over the contents. So, from the last session, what we learned was that we laid the foundation for understanding Web3 technology, blockchain technology itself. And some of the key takeaways was that Web3 is the next generation of the internet, and it's not just read, write, but own. It's about shifting power from centralized platforms like Meta or Google back to users. So we don't live in a world of digital landlords, but instead we own our identity, our assets, and our data. And we also learned how blockchain was introduced using Bitcoin as the first kind of decentralized money, and there's no need for a central bank. And we covered high level on what Ethereum is and how it extends the idea of allowing code or smart contracts to be automated, thus living on the blockchain. And as a result, this has enabled new forms of coordination, new forms of applications, or as we might know as dApps, decentralized apps, and of course, protocols, which are mostly open and permissionless. But of course, there are permission examples, which I will go through in a bit. And underlying all this technology, it's all done based on trust and proof of work. And this is a kind of consensus mechanisms used by miners to solve puzzles. So mining may be a term you've heard very often, like mining for crypto, mining for Bitcoin. Essentially, the computer is undertaking work, solving complex mathematical puzzles in order to secure the network for you. And on the other hand, we have proof of stake, which is used by Ethereum today, where if you stake a certain amount of tokens, you are permissioned to run validation blocks, which are incentivized for users to get a sense of rewards when they complete the task for validation. So on the agenda today, we will go through the blockchain trilemma, touch upon permissioned and permissionless blockchains, blockchain architecture. If we have time, I could talk a bit more about EVM, but ideally I'd like to cover the NFT section as well, which will be most interesting. So the first part will be on the blockchain trilemma. So initially there was Bitcoin, and it was revolutionary because it's digital money that doesn't require a bank or a government or a company. And then it evolved into something we all know commonly as Ethereum, which expanded the idea of decentralized money, allowing us to run programs on top of it using smart contracts, which then led us to touch into DeFi, decentralized finance, where money is hyper-financialized and moves around 24/7 without the need for a centralized authority, and also NFTs, so which are digital store of information that could be represented by anything, such as pictures, so JPEGs, videos, are basically a token. And this also allows participation into DAOs, a decentralized autonomous organization, which is a group, a community of people that is governing something, and their recognition is done via tokens. So this concept meant that we allowed new blockchains to emerge outside of what we know as Bitcoin. There's also the likes of Ethereum, Solana, Optimism, Polygon, and Avalanche. And these are all examples of different blockchains, but Ethereum is the most powerful one. However, it is also the slowest because lots of people use it. It is also expensive when demand is high. And some might argue it's not as decentralized as we think. As large institutions, individuals can buy up these Ethereum and stake it to validate the network. So, for example, BlackRock, Fidelity, and maybe Animoca brands has a lot of Ethereum, and we're staking in the network, and our say might be much greater than an individual's. So you could argue this is centralized to a certain extent, but not so much as we see as government organizations. So if builders want to work in this world, how would they tweak the design to make blockchain more accessible or cheaper? And that's where other chains such as Solana, Avalanche, Polygon existed, and they tried to fix the issue of either its speed, security, or scalability. So this is where the blockchain trilemma comes in. So you can't really optimize for decentralization, security, and scalability all at the same time. And normally you have to pick. So most blockchains choose two to be specialized in, and you compromise the third. So this allowed for different design paths to emerge. So Solana and Avalanche have different trade-offs, such as speed or throughput, whereas other L2s like perhaps Polygon might prioritize security and decentralization, just like Ethereum. So each chain has a different answer to this blockchain trilemma, but ultimately the performance and the delivery of the result is the same. So in the next section, we will talk about permissioned blockchains. So not all blockchains are open. There's permissioned and permissionless. So not every blockchain is also fully permissionless. So there's always some kind of control. Permissionless means a system in which anyone can enjoy and participate without approval. And we often associate blockchains with openness and decentralization, like on Bitcoin or Ethereum. But in reality, a blockchain isn't just one thing. It's a spectrum of openness. So there would be institutions or organizations that have launched their own blockchains, and those could be permissioned, whereas other people could use blockchain technology built by, let's say, Optimism or OP Stack or Arbitrum Stack in order to fork a version of their chain, and that can be permissionless. So a good contrasting example is like Bitcoin versus Ethereum, and how a permission environment, no permission environment could be undertaken. So in Bitcoin, anyone can create a wallet and start mining with a laptop and receive and spend Bitcoin. So there's no gatekeepers, you just have to join. But perhaps maybe joining this system might be expensive because of the hardware you need. So you might need a fairly decent computer, or currently this year, you need a very advanced computer with a very expensive graphics card. Normally the top tier NVIDIA ones would do well. That's why the stock is very high. But this is one example. But if you compare that with Ethereum, Ethereum is still open and permissionless, but there's a small twist. You actually have to, there's a sunk cost behind it. So you can't interact the network unless you have some Ethereum to pay for gas. However, when you create a wallet, you need somewhere to claim or send your Ethereum to. So this is a slight barrier because in practice, it may be easy to get Ethereum from an exchange or a friend. So we still consider Ethereum permissionless. However, without any Ethereum, it's almost impossible to get started because you have to pay some kind of gas fee for any transaction. On permission blockchains, access can be restricted, and it can be restricted via code. So perhaps only specific addresses are able to validate and even send transactions. So it could be a list of 10 banks or a list of government agencies or a select group of companies that operate within this blockchain and share the same structure, the same cryptography, but it's not open to anyone. So this is using just blockchain technology on its own, but it's a network that it's not allowable for regular people or retail to use. It's essentially used as a digital ledger that conforms and has rules that are written by all the participants that have created it. And this then leads us to four main types of blockchain structures that we can see out there. So mainly we have public blockchains, private blockchains, hybrid blockchains, and consortium blockchains. In public blockchains, anyone can read, write, and validate. It's fully permissionless, like Bitcoin and Ethereum. An analogy is like it's a public park and anyone can walk in and use it freely. Private blockchains, on the other hand, are run by a single organization, and only invited participants can use or validate the network. It's more like the corporate intranet, where it's efficient but it's closed, and it only showcases the information that they deem you need. It's often used for internal operations or a ledger of sensitive data. We also have hybrid blockchains, which combine an element of public and private. So it could be like a company stores internal data, but some of the anchors and proof of data and ownership is on a public chains for transparency. It's like a gated community with a public road running through it. And finally, we have consortium blockchains. So these are controlled by a group, like banks or enterprises, and participants all share different responsibilities. It's a permissioned and decentralized private chain. So it's almost like a shared boardroom, governed in real life, where users can vote and participate. And a good example of a chain used would be for DAOs, where decentralized autonomous organizations are able to vote virtually on different proposals and governance surrounding their institutions. So when we decide the characteristic comparisons between permissionless and permission blockchains, we have to consider the different benefits and drawbacks and decide which is a better use case for your particular purpose. So if you want maximum openness with community trust, censorship, and resistance, you would go with a public permissionless chain. However, if you need speed, privacy, and control, like for enterprise systems, a private or consortium blockchain would be better. So there really is no good or bad. It just depends on the purpose you want to use it for. The next section, we will talk about the modular architecture. So in the last section, we spoke about the trilemma, how blockchains have to work around the construct of the trilemma and often have to forego one feature in order to specialize in the other two. But blockchains are built in a modular way. And the challenge of balancing scalability, security, and decentralization and compromising architectures have been difficult. However, the constraint has been able to be resolved by forcing all three of these elements into a single vertical. So what this means is that each component or feature of the blockchain can achieve a greater efficiency by having it separated and allow for builders or developers to construct frameworks under each section and then to stack it on top of each other, just like Lego. So the crypto community often increasingly agree that monolithic blockchains, so that's where transaction execution, consensus, settlement, and data availability all happen on a single chain. It's better, but it's not the optimal path to scaling. With modularity, these separating functions across the specialized layers unlocks vertical and horizontal scaling. So the developers have more flexibility when they design applications and ensure systems can adapt more easily when the technology evolves. So we see modular systems start to take shape. So like Ethereum's roll-up centric roadmap, where new players like Celestia and Pyth have come in to take the role of data availability so that Ethereum could store less memory and run on a much faster basis. So here are some of the names. that we may see out there, and most have their own tokens, but they are often part of either a monolithic or modular ecosystem and perform specific use cases that allow for the blockchain to run more efficiently. So, for example, ZK rollups, you might have heard of ZK Sync and Starkware. This is where they can use zero knowledge technology and proofs in order to allow less data to be stored on chain because the rest can be verified elsewhere. You'll also have side chains like Polygon, which are known as an L2, or Optimism and Arbitrum, also L2s, but using a rollup system. All of them settle aggregated information on Ethereum. So they don't have to settle all a single transaction every time on the mainnet, which is Ethereum. They can bulk 100, 1,000, or 10,000 transactions together into one proof on Ethereum in order to save cost, time, and it's more efficient for the applications to run as well. There are other layers also, like L1, L2, L3s, and L0s. So L1 is known as the base layer, which is ETH, the main highway for data availability, for consensus and execution. Hence, ETH is the most expensive to run things on. Then there are the roll-up layers, like Base, Poly, Arbitrum, Optimism, that aggregate information so that throughput is higher, fees are lower, and it's more composable, scalable, and it relies on ETH as its security layer. So to really understand how modular blockchain scale, we should look at the different building blocks required within L1s and L2s. So L1s are base layer, and they take care of everything. And it's the main highway for which information is stored, information is gathered, and also verified. Whereas L2s are like the subchains or the side chains, and they help in terms of making things more efficient, making things cheaper, and also allows for higher composability and lower development costs across. So some of the key definitions that or wordings that you might come across when you read about the different layers are words such as rollups, sidechains, and bridges. So rollups are bundled off-chain transactions, and then they submit as one on the mainnet as a proof. Sidechains are independent blockchain networks with their own sets of validators, but they connect to the mainnet. Sidechains are riskier because sidechains could be hacked, in which all these tokens could be drained, as the connecting highway could be vulnerable to smart contract risk. So most of the major hacks you've heard of, such as on Ronin, those are because of sidechain hacks. Bridges are a bridge that facilitates the conversion of one native asset into another. So, for example, you might have USDT on Ethereum, and you could move USDT onto Arbitrum. It has the same value, but the token functionality is just on a different chain. You might want to move your tokens from Ethereum chain to Arbitrum chain because the cost of transacting is very different. So a regular transaction on Ethereum might cost you $1 to $4, whereas on Arbitrum, each transaction might be costing you 1 cent. So if you were to participate in DeFi, like use the Hyperliquid, which is a popular exchange platform to buy and sell cryptocurrency, transacting on Arbitrum could save you more than 40x the cost. So that is why bridges are commonly used to convert one native asset to another. So L0s can be thought of as the underlying software infrastructure. So they are responsible for chains communicating with each other. So a very common one is Chainlink's CCIP protocol, cross-chain interoperability protocol, which allows different blockchains to talk to each other and send information across. One popular company is also called Layer Zero, that acts as that underlying layer, a subsidiary of Animoca. On the other hand, we have L3s, but L3s are more known as an extension of the blockchain. They're ultimately dApps, decentralized applications, as they run on top of these protocols. So these are front ends with nice user UIs and UXs where customers can interact with, and it's essentially a product. So it could be a NFT marketplace, it could be a crypto wallet, it could be decentralized exchanges, it could be lending protocols, and it can also be NFT community websites and DAOs, or even a game like Axie Infinity or Gunzilla. These apps now can also exist on the mobile network. So you can download it on iOS, for example, Pokemon Gacha tokenization marketplace called Courtyard, where you can pull Pokemon in there, but all the Pokemon cards are on chain and you claim it for the physical product. That's available as well. And other games such as My Pet Hooligan, roguelike FPS, which you can download on iOS. So as you can see, the blockchain is just the underlying infrastructure that we can run a lot of applications on. And in the future, or the future we're living in right now, is actually a multi-chain world. So ultimately, when we talk about the blockchain, a user should not need to know what it is hosted on. Just like our car, it's not too important what engine it runs on. The car would take us from point A to B. If you're more specialized, you might want one that's more powerful. Therefore, it's like a chain. You might pick one that's more faster. So the most important stuff is that the chain works as it should, and it should not have any downtime. So any time that it's not running, and the application should serve the purpose of solving a real world problem, such as the efficiency of the movement of money through tokens, or the ability to own our assets so that we will not be deplatformed by anyone. So the content we create or the game assets that we've acquired, that we have full ownership over that. So this means that there is a parallel world where the metaverse or the digital verse exists, where we can run the same types of ownership that we have in real life, but instead of those types of ownership recognized by governments or institutions, ownership is recognized on chain in the digital world and validated by thousands of individual nodes run by institutions, networks, or other people. So EVM is the next part we will talk about. EVM is known as Ethereum Virtual Machine, and it's the computation engine for smart contract functionality. And the purpose of EVM is to allow the state of a network to be programmable and the state of the network to be recognized using a common language that uses the same kind of storage across board, so that developers all over the world can look at open source code and contracts and start building upon it. So many chains use EVM because it uses a common language known as Solidity, and it also allows very easy migration across many different chains. And ultimately, there's one single shared library that hosts a lot of different smart contracts that you can build a lot of frames around, which eventually rolls up into products. As more people work alongside the same system, the ecosystem can grow faster. And this is through something we call network effects. So network effects multiply as a user would be using the same and interacting with similar touch points across different products, but they all feed into the same underlying system, which is the Ethereum protocol powered by the Ethereum virtual machine. Hence, as more people enter into the blockchain space, if they buy an NFT, they create a wallet, they acquire in-game assets, or they've made some token trade somewhere, it is likely that they have interacted and used Ethereum token. Therefore, the price of Ethereum um, has a lot of has been increasing recently through the demand of not just the blockchain but also speculation that this will be the future financial system that has the potential to increase financial rails and could replace the current environment that we live in. So many chains are compatible with Ethereum, such as Binance Smart Chain, so BNB, and the guys behind Binance Exchange. There's Arbitrum, Polygon, Avalanche, Optimism, Phantom, Chronos, ZK Sync, Starknet, Base, and many more. Because of the shared infrastructure, the cost of developing is much lower, and there's a very wide use base for the whole developer ecosystem. However, it's not all the pros that people see in the EVM. Of course, there's strong network effects. There's a larger crypto ecosystem to pull money and have users test products. It's relatively easy to fork to create other chains. And there's a very large token standard, and they benefit from the Lindy effect. However, the cons of building on around the Ethereum virtual machine is that the finality of transactions, so the speed of the chain that verifies information can be slow, even though can be slow, and that transactions are sequential. So what we mean by this is transactions have to wait for the first block to be completed, whereas the other chains right now, like Sui, which offer parallel transaction execution. So it means there can be multiple rows of information being submitted at the same time instead of waiting for the transaction in front of you to complete, making sequential transactions much slower, which is the underlying way of how Ethereum consensus works. There have also been complaints about bad UX UI integration with EVM smart contracts. Perhaps that's due to the complexity and the modularity, the stacking of information required, which has been a major bottleneck for dApps built on EVM at the moment. However, security is generally quite high, as Ethereum has not been hacked before, unlike other chains, which are much more vulnerable to this risk. This concludes the more technical section for this part of the series. And after this, we'll go into NFTs. But before I go into NFTs, do we have any questions around the blockchain architecture? No questions. Okay. All right. So this part will be on NFTs, which is known as non-fungible tokens. So non-fungible tokens are a digital container that can store anything. And most commonly, we know them NFTs as PFPs because the smart contract is calling and pointing to a picture that is often saved on a server somewhere, like on IPFS or AWS Cloud or Google Cloud. It can also point to a video and also point to data storage capacity. So NFTs are just a representative token, and it can store any kind of information in it. So some of the key properties is that it's unique. So no two are the same. There's provenance. So there's an on-chain ownership history. You know when it was first created. You know which wallets or who it has passed on to, and you can essentially track everything that's happened to it. And it's almost impossible to fraud on it. So because it's transparent and on-chain. It can also be programmable. So NFTs carry utility, royalties, and perks. So very commonly, what took off NFTs was that artists could be compensated for their work even after the secondary, third, fourth, fifth buyer. These are known as royalties. So they could mint a picture, JPEG, an NFT, and it could sell for $100, $1,000 next, 10,000 next, and so on. And every transaction, the royalty could be 5% or 10% to the original art owner. So this creates a powerful notion, particularly for creators, which are very undercompensated in the world we live in. And people often steal other people's work and claim it as their own. So NFTs and the use of blockchain and programmability can resolve this. So examples that NFTs are used are in art. So here in the picture on the right, I have a Dmitry Cherniak Ringer's NFT, which sold for $6.2 million on Sotheby's. There's a physical piece, but there's also NFTs, which you can redeem for their physical. And this is a form of tokenization, real world asset tokenization. NFTs often used for art and collectibles too. So in collectibles, we have Pokemon cards on Courtyard, where these slabs or PSA graded cards are vaulted with Brink. The digital representation of them are raffled and sold on a marketplace. You can transfer it to someone, you can sell it to someone and receive crypto in return, like USD, stablecoin, Ethereum, or Polygon. And any user that owns it can decide to claim it, and these guys will ship it over to you. This immediately increases the liquidity of essentially something that is fairly illiquid, where you have to go to a shop, meet up a person in real life, or go to a card show in order to offload these kind of niche items. So the same can be said for in-game items, where users can own digital skins that they own. So Pudgy Penguins recently launched the Pudgy Party game on iOS. And if you have a NFT, you would also be able to collect some special skins, and skins can be sold for tokens, so US dollar money or other currencies. So this has been replicated just like in real life, where we play Counter-Strike, or you might play Dota and other digital games where there are skins that you have to purchase for $1 or $2. But now these skins are now liquid and you can transfer and sell it to someone else. So all this is powered by NFTs and has been very useful over the past couple of years. So NFT roles and ecosystems are manifold. So they can give access and membership to gated communities, to be part of a DAO, or to go to events. So think of it as a membership card, but instead of that, you can also attach identity and reputation on top of it. So on the bottom right here on the screen, we have the Mochaverse NFT collection, which is Animoca's own NFT collection. And essentially, it's your identity and reputation in the Web3 world. So once people recognize it, they will affiliate to you. So the top left one, I think, is our chairman, Yatsui. So this is his PFP on Twitter, and it's a representation of Yat. So every time he makes a tweet or he makes a Medium post, when someone looks at the picture, they know it's Yat. So this is one way that you can start to curate your online identity, and perhaps this can give benefits such as airdrops of other tokens, invitations to participate in other ecosystems or games, or even ventures or investments. So these gated communities can use NFTs to represent them being a member in the space. It also creates a community for people to talk about things they have in common, whether that's trading, hiking, traveling, Web3, or just regular stuff about life. There's often a discourse place where people can discuss and meet others, like-minded, all connected through the same community PFP that they're a part of. There are also other benefits that can be noted using NFTs. So revenue sharing is one common way. So it's possible that having an NFT means you're having a stake in the ecosystem they're building. So any revenues or royalties could be shared with all the members. So, for example, for Mochaverse NFTs or having the Mocha token, you would receive something called staking power, which you can commit to be part of the $20 million fund that the Mochaverse team have a project have gathered together, and all the community members have a split over that over time. So NFTs are interesting to use as they're digital tokens that can give you different kind of benefits used in games, used in community events, used in DAOs, and also used for identity and reputation. So this is the Mochaverse example where all community members with either a Mocha token or Mocha NFT that have staking power are able to have a share of the $20 million portfolio fund that Animoca Brands has invested in via Mochaverse. So this is a useful way to garner more attention for your community and also to give back the revenue that you have generated for those that have supported your ecosystem via providing them with their network effects thereafter. So why do NFTs matter? So they are an economic layer that allows new markets to be created. So a marketplace is an often common example, like OpenSea, Blur, and Magic Eden. They also allow the hyper-financialization of certain things, such as in-game assets or even identity, because they're often recognizable and there's some kind of niche digital value attached to them. There's also a behavior layer that we could tack on with NFTs. So gamification, engagement, and loyalty. Gamification using NFTs is interesting because it allows you to play with different intrinsic and extrinsic motivations of a user by understanding their on-chain interactions. As the minting of an NFT and ownership often allows on-chain sleuths to identify the different types of habits that a user does on chain, like how they interact with their tokens, how they trade, and it allows us to gamify their interactions for the next product they want to undertake. There's also the financial layer. So using NFTs to loan, so becoming a new form of collateral or become a yield bearing token on its own. So you're able to loan out your NFT or provide loans to NFTs in order to get yield. And these features are often available on Blur, Magic Eden, and OpenSea. And these allow users to have liquidity over the digital assets that they own. And it also allows them to utilize their ETH for some trading purpose without the middleman, essentially allowing them to take on the risk that they want. So in future, more often NFTs may be seen more as a luxury product. So these JPEGs have become financial primitives and identity rails because you often associate certain thought leaders with their digital profile picture that they have used. So like Yat with their Mochaverse, perhaps Mo with his Bored Ape, Elon with his the creator Pump Fund with his CryptoPunk, Lucanets with his Pudgy Penguins, and maybe Pharrell with his Doodles. So these are all notable NFTs that have become common PFP used by thought leaders because when users see that picture, they often associate it with some sort of expertise, know-how, or just DGen OG knowledge of the space. Of course, these NFTs can be bought, so they may not be a true representation of their reputation. So often someone would buy an NFT that was once owned by a famous person. So these are some interesting things that influencers and thought leaders can use to leverage on marketing. Of course, there are users that have stuck to the same profile picture and it's not been transferred. So that represents the same person that you have been interacting with on the internet. So personally, I think NFTs are extremely useful and interesting. I think they're very applicable in terms of online identity reputation and also tokenizing collectibles on its own. The ability to provide liquidity to relative illiquid assets is a strong form of use case. And I think this is the RWA, the real world asset industry, is something that can really be propelled by the use of blockchain technology. Thank you for listening, everyone. That concludes the NFT section. I'm also open to questions here. You can ask me anything related to the contents or anything Web3 related as well. Happy to answer.